Going.
All right. Well, so let's kick it off. Hello everyone, and welcome to another All Things Waterproofing webinar. Because my LinkedIn page is called All Things Waterproofing, we must start with waterproofing. So this will be the focus of first part. And the second part will focus broadly on benefits of green roofs with emphasis on detention roofs and how we can utilize them as an effective stormwater management tool. And this will be presented by Robert. And speaking of Robert, Robert is an international expert in the field of green roofing. He worked all over the world implementing green roof and vertical garden projects. He's a managing director of Evolvement, a company specializing in green roof and vertical gardens installation. In addition to that, he's an Urbanscape green roof technical advisor and installer here in Australia. This post, which by the way appeared in my feed just as I was writing this introduction, is the reason why I want to talk to Robert about green roofing. He completed his first green roof project in 1981, so 5 years before I was born, and I figured it's just about as good of a source as I can get. Now, a little bit about me. My name is Jacob, and I'm a roofer and waterproofer by trade. I also do some consulting and membrane testing now. I work for Waterproofing Integrity also lately, doing some membrane integrity testing around Queensland. So I also run this LinkedIn page called All Things Waterproofing, mainly for fun, but also to compile interesting information about waterproofing and roofing. I also organize webinars from time to time on whatever I find interesting, but related somehow to waterproofing. So learning objectives. So Robert will cover a little bit of that too. But from my point of view, I would like everyone to understand basic principles and benefits of green roofing, learn basics about waterproofing and testing of green roofs, understand basic principles of detention roof, and learn how we can utilize detention roof as an effective stormwater management tool. Now, housekeeping, if possible, please keep your microphones on mute until the QA session. And we are recording this, and we might post it on web, as I mentioned before, if it turns out nice. And please post questions to the chat, and we will try to answer them in QA session. Just post them in the chat so we don't miss anything. And if we don't have enough time, I think we can also address the questions in the post, in the LinkedIn post. And I would like to open my presentation with the question, why not a green roof? I think at this point, it's pretty obvious what are the benefits of green roofs, and Robert will cover that in detail. Why then, whenever I propose a green roof for a flat roof area that will literally serve no other purpose to anyone, I come across with so much resistance. Loss aversion is one of the reasons, but that's just my theory. The article in Journal of Cleaner Production that Robert co-authored describes a lot of well-defined issues that we are facing, which are delaying the progress of adoption of green roof technology in Australia. And one of them is hesitancy of engineers and designers to utilize green infrastructure. And I think from waterproofing industry person point of view, the reason for that is quite obvious. The risk associated with waterproofing a green roof. And one of the key questions I would like to answer in this presentation is, how do we manage the risk associated with green roof waterproofing to increase confidence in our ability to waterproof green roofs effectively? So let's start with the waterproofing design considerations. So please keep in mind that this section of presentation is describing considerations for roof support purely from waterproofing perspective. There are other considerations like structures loading capacity, wind resistance, fire resistance, and accessibility that have to be taken into account when designing green roof. However, this will not be discussed in this section. Now, to keep it simple, we have concrete substrate and we have lightweight substrates. Concrete is a stable substrate and it doesn't move much. It cracks, however, so that have to be taken into account when selecting waterproofing type. Lightweight substrate, on the other hand, moves a lot more, and that movement and joints have to be considered when designing waterproofing system. I personally feel that lightweight substrate are the future of building industry, and the technology advances will allow us to build taller and taller multi-residential buildings. And the best example is the new Atlassian headquarters building, a 180-meter, 40-story timber steel hybrid tower that will be built adjacent to Sydney Central Station. That's a very interesting project particularly from waterproofing perspective, and I'm just very excited to see what the waterproofing design will be all about in there. Now, this is also very much simplified, and I don't have time to get into details of exactly how each assembly works from thermal efficiency point of view and internal environment controls required. But in principle, there's 3 different types, 3 different options of where a membrane can go in the roof assembly. So first of all, if there's no insulation in the assembly, the membrane can be adhered or loose laid directly on the support. Membrane also can be overlaid with insulation, and that's called inverted roof. So it's a very popular type of assembly that we see a lot in Australia. And the last one is the warm roof. So that's the assembly where waterproofing membrane is above the insulation layer. And that type of assembly generally will require vapor control layer. And that sort of comes with some additional considerations from waterproofing risk perspective. Now, for a second, forget what's above the membrane and think about waterproofing only, right? So consider repairability and membrane attachment options. So there's really 2 options for how membrane will be attached to support. It'll be either bonded or it will be unbonded, right? So bonded, particularly for concrete support, is a great option because if the bond of the membrane to substrate is strong enough, even if there's a breach in a substrate, it is quite possible that we still will not have a leak because there will be no lateral water movement. Now, on the other hand, with unbonded membrane, which there's good reasons to use unbonded membranes in certain assemblies too, because unbonded membrane, for example, will be independent of support, and the stress will be a little bit less on this type of assembly. However, if it gets punctured, then it is very likely that lateral water movement will occur, and that will make it more difficult from repairability point of view. These unbonded membrane roofs are generally it's a little bit more difficult to find a leak in them. Now, falls. There's 2 options. So a fall in structural deck, or for example, for a warm roof, and I just included tapered insulation because I really like that option. But it could be also a screed. So there's either fall in the structural deck, or the fall can be built on top of the structural support. And currently, the minimum required fall for as per Australian standard is 1 in 100. However, currently the mainstream thought in waterproofing industry is to get rid of water as soon as possible. And it does make sense from waterproofing risk management perspective. So there's this whole redirect, collect, and drain approach, right? That does make sense. However, that really doesn't help us when we think about stormwater management, which I am, again, not an expert in. Robert will discuss that a little bit more. And I also thought, because obviously detention roof is just kind of like an ordinary membrane roof that can be compliant with that 1 in 100 fall. That's no problem there, right? But I was thinking, what about no fall? I was just considering blue-green roofs, and this is something that it's more and more utilized in Europe and in America, and I thought I would just bring that up and maybe do another webinar one day on blue-green roofs. But that's not the subject of this webinar. I just thought that it's interesting, and it's a good time to put it in a slide. Now, waterproofing system requirements. So even though we established that the structural deck is generally required to have a fall in it to comply with the construction code, it is important to note that green roofs, and especially detention roofs, will get saturated in a rain event, and at some point, water under hydrostatic pressure will be present in this assembly, right? So again, fall or no fall, there's some redundancy that's required in this type of assembly. So that's why all green roof assemblies should be hydrostatic. So that means they should be watertight, even in presence of water under hydrostatic pressure. And all the waterproofing people in the webinar would know very well that like a lot of the membranes that are used for green roofing, they can also be used as tanking membranes, right? So they can hold a lot of hydrostatic pressure. There really is not a big problem, right? So now I always like practically no presentation go without Mr. Michael T. Kubel for me. He wrote this book on that's called Construction Waterproofing Handbook, and he formulated two very interesting waterproofing design principles. So first principle tells you where the things can go wrong. It's a 90% one principle, and it basically tells you that where things go wrong, they will go wrong at terminations and transition detailing. And the other principle is 99 principle, and that principle tells you why things go wrong. And the main reason of waterproofing failures are generally human installation errors, wrong system being specified, wrong or no primer used, inadequate prep work, incompatible materials being transitioned together. But also I've added damage by others, because that's very relevant, particularly to green roofs, right? Now, selection of waterproofing membrane, I try not to dwell on it, but like everybody who knows me, they know my love for modified bitumen membranes. And they're usually bonded two-layer systems that are heat welded. They're robust and puncture resistant, easy to test and verify the installation for most part. And the only thing to consider are the safety measures, right? Because usually, very often, open flame is required to install these membranes. And now, single-ply synthetic waterproofing membrane. I hate to admit it, but these seem to be almost better in green roof assemblies. There's many reasons for it. First of all, it's just that they're generally single layers. They're wider, longer rolls. There's less seams. But also inherently very good root resistance, particularly PVC membranes, that they're very root resistant just naturally. And they're robust and puncture resistance and easy to test to verify also. Now, butyl rubber waterproofing membrane, I was a little bit skeptical when I first saw it, but it's very popular in Australia, and I actually love it now. The butyl rubber waterproofing membrane. I think Ardic's the only one who sells that at this moment, but it's an excellent system. They're usually single ply, can be bonded or unbonded, easy to test and verify. And liquid membrane, now also everybody who knows me know that I am not a big fan, but I didn't even want to include these, but then I felt like it wouldn't be fair, right? So they're still suitable for, particularly for concrete substrate. They're not any good for lightweight substrate, in my opinion. Like some might argue, and they might say that if you treat the joints properly, it can be utilized. However, in my opinion, for green roof assemblies, we should generally go with the robust sheet membrane system. And now, as far as manufacturers go, right, most reputable manufacturers have products suitable for green roof waterproofing. All you need to do is to just to establish that the product is suitable for what you're trying to achieve, right? Now, waterproofing membrane compliance. So that will be a very brief slide, because there are people that are more qualified to cover that than I am. So Australian standard for external waterproofing AS 46541 and 2 covers materials, design and installation of external waterproofing membranes. And there's a variety of membranes that comply with the standard. As far as installation go, the standard is 10 years old now, and it didn't age well. So it is very often tricky to prove full compliance with part 2 of the standard. But don't worry. Luckily, we have a performance-based code. Therefore, we can still just meet the performance requirement that are outlined in the NCC. And frankly, if the roof does not leak, then it likely, and it's maybe too simplified, but it will probably be compliant. Now, maybe in the new revision of standard, which I know it's getting revised soon. I was just talking to Frank about it today. Maybe it would be good to include some more guidance related to waterproofing of green roofs, because there are some considerations just very specific to that. And Byron mentioned planter boxes, which in my opinion are actually but similar, but they're a little bit different to green roofs, right? So I think we have to include a little bit more information for the industry people. And now for further information on compliance, go to there are interesting courses on Construct New South Wales website, some on waterproofing, but also on other building industry related subject. Waterproof.org.au, that's Australian Institute of Waterproofing, so that's our industry association. A lot of very helpful information out there, and there's also a directory there that that you can use to find members, basically, to help you with your waterproofing design if needed. And waterproof awareness, so that's Byron and his webinars. They're quite helpful, and if you want to educate yourself on waterproofing compliance, it's definitely worth your while. Now, root resistance. So Australian standard says that if the membrane is not protected by root resistance barrier, it should resist attack from root systems that might cause it to degrade or puncture the membrane, right? So we can use anti-root additive, and that's pretty common for, say, liquid membranes or even bituminous sheet membranes. Or also there are, like I mentioned, PVC, for example, is inherently root-resistant membrane, right? And now, in absence of test method, I always refer to that FLL method. So that's the Research Society of Landscape Development and Landscape Construction. It's a German association, and they've came up with this test. Just to describe it very briefly, they defined the size of container and how the container for the membrane implants is built. They defined how membrane should be spliced, how to create suitable overlaps to be exposed to the roots, and then it specifies the spacing of the plants, and it also and the types of the plants. But also specifies the period of time where the membrane is exposed to the root attacks, right? Now, to summarize, key items to consider when selecting waterproof system for your green roof. Waterproofing system should be suitable for the type of roof assembly you're building. Waterproofing systems should be supplied by a reputable manufacturer and installed by trained certified applicators. Read your warranty. Is 20-year product warranty really what you need? Compare apples to apples and really read the fine print. Read that product warranty and actually consider what's being offered to you. And consider engaging third-party consultant to help with the design, testing, and commissioning of the waterproofing system. Now, waterproofing membrane testing. So we will describe some more sophisticated methods of testing in the slides that will follow, but just knowing that there is a breach in membrane is not enough. Long-term performance should be also considered. So compliance with manufacturer standards should be confirmed by either third party, or it can be also confirmed by membrane manufacturers. If it's their membrane, they can confirm it's been installed correctly, I suppose. So unfortunately, there are limits to what I can see, and some help from modern technology is necessary. So for liquid membranes, we have we can test the thickness of the membrane, we can test the adhesion of the substrate, we can also verify continuity, right? Now, ELD, so that's electrical leak detection. So there's two different methods. There's high voltage and low voltage, but both of them use electricity and simple electric circuit to detect and identify problem conditions in waterproofing systems. Now, the concept of high voltage test is pretty straightforward. A technician applies electric energy to waterproofing system with an electrode. The electric energy is prevented from flowing by a continuous non-conductive membrane. Discontinuities or breaches in the membrane, at discontinuities or breaches in the membrane, energy can flow in the form of current from electrode into the electrically conductive substrate located below the membrane. Electricity will only flow if a complete circuit exists, and the flow of electricity alerts the technician to precise location of the leak. So that's me performing high voltage test in one of the waterproofing integrity projects in Brisbane. And I took short video. However, I can't make the sound work for whatever reason, but you can still have the visual. So whenever I get to the breach, the machine signals it, but also, as you can see, there's a spark that goes into the substrate, and that's why high voltage test is also called a spark test, right? Now the big advantage of the high voltage test is that it's a dry test. It's simple and effective, but the disadvantage is that it cannot be used after overburden is installed. So the second testing method is ELD, so low voltage test. So there's two different options for that, actually. There's vector mapping that works by isolating a section of newly installed membrane using a trace wire. The conductor loop is then connected to an electrical pulse generator, and if non-conductive membrane is wet, the circuit is completed when there's a breach in membrane. With the scanning platform, that's a DTEC system. I think, I don't know if it's unique to them. Maybe it might be, might not be. I'm not sure. But the scanning platform, the basic principle is the same. However, the scanning platform itself is isolating the section of membrane, so there's no need for a trace wire. And both methods require surface of membrane to be wet during the test. And frankly, I don't have much experience with low voltage tests, so I'm not an expert, but I would like to learn more. And it's almost, I think it would be worth our while to do another webinar just on all ELD or different methods of electrical leak detection systems. But maybe I'll just get suggestions from everyone in the QA session. Now, what about non-conductive substrate, right? So if we plan ahead, we can include provisions for incorporating of conductive underlay into our assembly in one of three forms. So you can either have conductive underlay or aluminum foil faced insulation for high voltage test, or we can use this mesh directly under membrane for vector mapping. Or another option is this conductive primer. That's again a product from DTEC, and I never actually use it, but it's quite interesting. It apparently works for both low voltage and high voltage method. So it's just basically a paint-on conductive underlay that could be directly under waterproofing membrane. Now, flood test. If we cannot test with ELD, we have one more option. So flood test is better than no test. It's still the most common testing method, I think, in the waterproofing, where it just you don't really need any sophisticated equipment, just lots and lots of water and some dye. But it cannot be performed at locations where the underside of the slab is not accessible. And it's helpful to find location of the leak if membrane is bonded. However, if it's unbonded, we will only know that the membrane leaks, but we will not know where it leaks, right? And it's not always possible or practical to perform, right? Like for example, for really large roofs, it just can be a real pain in the butt. So also permanent leaks, permanent leak detection systems. These are designed to be incorporated within the roofing assembly, so particularly for warm roof assemblies. So sensors are laid out in a grid pattern, and they're activated by moisture. Sensors will then signal to a computer system with the location of the water ingress when it occurs. Now, this is quite a sophisticated system, and it can be very useful with warm roof assemblies in high-risk scenario. And just interesting fact, the new revision of British standard for below-ground waterproofing now requires permanent leak detection systems to be used when warm roof assembly or loose laid membrane is used for waterproofing of buried decks. So which I totally agree with for buried decks, that it's a high-risk scenario, and they effectively just, like, instead of banning it, they just did that, which that will probably just exclude people will not want to do it, I suppose. So I don't think that the same approach should be taken with above ground stuff. I think these are quite interesting and like really sophisticated system. However, if we are to mandate them, we will probably kill most of the green roof projects, and that'll be a terrible outcome. And I think as much as I think it can be helpful, but like I would only use it in like very, very high risk scenarios, right? And now membrane protection and damage prevention. So it's important to arrange a pre-start meeting to make the requirements for membrane protection clear. What's obvious to waterproofers is not always obvious for other trades. And limit and identify the damage to membrane system during construction. And stage waterproofing works so membrane can be protected as soon as it's tested, retest if necessary. Do not store anything over waterproofing membrane. And I like to bring out broken window theory for all waterproofing projects, not just green roof waterproofing. So the broken windows are a metaphor for any visible sign of disorder in an environment that goes unattended. This might include just a little bit of rubbish that's not being picked up, material scraps, coffee cups, energy drink cans, etc. Being forced to confront minor problems can heavily influence how people feel about their environment and affect the outcomes of waterproofing projects. So to simplify, if there's rubbish on the membrane that it's not picked up quick enough, like people will just start treating that membrane like a rubbish bin. They'll just keep throwing stuff at it and then trampling it. And like, if we don't respect that membrane, nobody else will, right? So, and last, membrane protection is mandatory. And waterproofing of green roof summary. So start with solid waterproofing design to suit the objectives of the project, mitigate the risk with redundancy in waterproofing system, use premium solutions only, use trusted waterproofing manufacturers with good track record and a chain of approved applicators, verify installation and test the waterproofing system before installing green roof, and protect membrane system after testing, retest if necessary. And we have sent people to space, and waterproofing is not rocket science. So please don't let the fear of waterproofing failure be the reason why you don't install a green roof. And this last slide is just my attempt at humor. I asked my wife if she thought it was funny. She said it's not, but I'm a big Jay-Z fan, and I just couldn't help myself. So thank you very much, everyone, and I'll hand over to Robert now. Yes.
Yes. Okay. All right. So detention roofs, we've sort of going to cover a little bit more on green roofs apart from just the detention roofs. So we're going to look at intensive and extensive green roofs. I'll explain those. Climate, energy and heat. These are all reasons for doing green roofs. Stormwater detention and food, biodiversity. These are other benefits, and the green roof components, and some research that's been taking place as well. So I will go through. So just a couple of failures here. Whoops, sorry, back to that screen. On the left-hand side, it's a green wall. It's failed. It looks particularly unsightly. So when you have a failure in a green roof or a green wall, you're going to expect to see something pretty awful. So you don't want that. And on the top right-hand corner picture, that is a shot showing where the drainage system has failed and there's too much waterlogging going on and the plants are dying from waterlogging. And the bottom right-hand picture is a roof which there could be many things go wrong with that. We'll probably cover most of these, but if the soil's wrong or the plants are wrong or the irrigation's not working, you'll have poor plant growth. And then what happens with that is you'll end up getting soil blown off roofs. And so you've got a section in the middle of that roof where there's no soil anymore and it's just showing bits of insulation and things like that, particularly unsightly. That roof is very large, and those sorts of failures become a major problem to the contractor and whoever else has paid for it. So the benefits of green infrastructure are maximising value for residents. This is a project in San Francisco, controlling stormwater, reducing energy consumption. There's health benefits. Many of these green roofs are used by people to relax and so forth. Busy offices underneath. There's local food production can be done on roofs. A large amount of green roofs, basically on the heat side of things, on the outside of your building, temperatures in Sydney and western suburbs were 49 degrees and 54 degrees and things like that last year. A roof, an insulated green roof or a bitumen roof will get to maybe 100 and maybe 200 degrees. I'm not exactly sure, but extremely hot, certainly more than boiling point. But when you've got plants on there, if the plants are healthy, it's impossible for the roof to get more than about 60 degrees because that's when plants die. So plants have natural transpiration, they shade, and so forth. So essentially the top of the roof cannot get so hot, and therefore things like heat island effect, which is the increased temperatures in a built up environment, are reduced. And so there's quite a bit of data on that. Carbon emissions, it's a matter of putting carbon on a roof, and improved biodiversity, and there's a lot to do with that too. So I'm not sure if we have any environmentalists here, but I could go on for that a long time. So there's mainly two types of green roofs. On the left-hand side, well, if you know that building, it's sort of on ground level, but there's 6 levels of car park below it. That roof probably weighs around 6 tons per square metre. It's an intensive green roof. It's a garden on a roof, and we call those rooftop gardens, essentially. On the right-hand side is a job at Bondi with a lightweight green roof on it. Has a low soil profile. It has succulent plants. It's not actually meant for humans to inhabit. The maintenance contractors will go up there and they'll use ropes to tie themselves on when they're working. But it's a roof for stormwater management, cooling. It does look good from buildings above, which are around it. So that's the difference. You've got intensive or extensive or rooftop garden and lightweight green roof or green roof. This shot is a building in the States, and it's got an intensive or heavy green roof all around the edge of it. And in the middle of it, it has a lightweight structure and has a lightweight green roof on it. The resulting effect of that is that that particular building site has about 80% green on it. So you can have the question of the heavy rooftop gardens for people and lightweight green roofs on the one building. These are graphs of climate change over the next 40 years, and the graph actually shows, this one's for Sydney. Yeah, the graph is made by a number of organisations, reputable organisations like the CSIRO and so forth. It's not anything political here, but they're showing that temperature change is going to be quite high in Sydney. It's going to change from 22.5 average to 26.5 by 2070, a long time away given that, but nevertheless, that's where we're going. So green roofs are important in that aspect. This is infrared, it's some thermal imaging. The left-hand top shot is just a green wall. It's basically ivy growing on a building. And the bottom left-hand side shows what the temperature of that building is at 9:15 a.m. in the morning, and it's around 25 by the colour, about 25 degrees. And then in the middle of the day, 1 p.m., where there's no greenery on that building, it's up red. So it's basically showing you the temperature of that building where the sun's attracted to it, and the rest of the building is still cool. So that's just showing what temperature can. And there's quite some interesting maps on this from aerial satellite imaging of cities, which show how hot and cold things are. So there's some very useful information out there on that. This is a graph of a building which shows 27% kilowatt advantage on this building if it has a green roof on it. I can't explain it, but the dotted red line is the temperature if it was just a concrete roof fluctuating throughout the day. The solid red line is the temperature inside the building, a concrete building without a green roof. The dotted green line is the temperature outside of a building if it has the green roof on it, in this particular building at North Sydney. So it just shows that the peaks and troughs are much lower. And on the inside of that building is the solid green line, just showing the temperatures much more steady. So that was all calculated at a 27% saving in kilowatt hours for that building. This is a lightweight green roof in England. This company advertises itself as the first carbon neutral beer. It's a few years ago now. But that particular building doesn't have any air conditioning or heating involved in it. It's got big double doors which the semi-trailers can drive through so that the temperatures are maintained inside, and it pretty well stays 20 degrees all year. So that's what they've done there. I worked in Stuttgart for a little while, and green roofs are mandated there. And this is a little industrial estate where every roof is green roof. And the reason for that is about stormwater management. The council themselves can put in smaller pipes in the streets, and we can, the streams and the creeks in this area flow much more steadily. I'll talk a little bit more about that yet. But the point of this slide is that many countries, it's Stuttgart, Paris, they have some mandated rules now, which mean that you have to have a green roof. And obviously that means a lot of waterproofing too for you guys. This is in Brooklyn off New York. It's very large vegetable gardens on green roofs. This is a very interesting project. I spent some time over there in this one, and they have contracts with about 100 restaurants around this area in Brooklyn. They all come to the gardens at 7 a.m. in the morning and get their fresh vegetables that have been picked only hours before, and take them back to the restaurants. And this sort of low mileage food and so forth is a big part of their advertising in their restaurants, and people eat there as a consequence. On the bottom left of this photo, this was their menu on one other restaurant I went to, and it shows every farmer and where all the produce is produced. And these sorts of restaurants are always full of people. And I was very surprised that Macca's over in the States there where I went was nearly always empty. So that's it, it's having a good effect for restaurants and so forth. So this is a photo of a just typical job here where we could have a building with a green roof on the right-hand side. Green walls. Then on the left, we could have and then on the very left-hand side, we could have what we call a brown roof. And this would be typically non-irrigated. It would be just a biodiversity area. And on the bottom left is a photo where I live in Barara on rockwork, where these little bushes, it's Micromyrtus blakeleyi, grows on about 1 centimetre of soil. And those trees are about 150 years old. So they're only about 400 millimetres high, but that's the sort of typical natural plant material that occurs. And the bottom photo in the middle is a photo I took after 10 mils of rain at Broken Hill. And normally that hillside is just covered in rocks, but after a very small amount of rain, it completely turns into a flower paradise. And those are the sorts of things that you might think about growing on a brown roof, if you like. This is a project in France, and it's got the full suite of system which I'm working with. I'll just try and show you what I've got here. So if anybody wants samples of this system, I have them available. But this is a system from Knauf Installation, a big company, and it's their Urbanscape system. And in this box here is, in this case, is a green roof, and the top level is the plants, if you like, on a bit of cardboard. And then we have a, whoops, just go back up that. I'll click that. And then we have a mineral wool layer. In Australia, I put a small amount of soil on top of this as well to make it easy. Then we put, still skipping slides, then we put drainage cell. There's various different types. And then a waterproofing layer from you guys. So that system's available. And we have another system, which I'll show you in a minute. So go back to this then, and then there's plants that are available. There is rollout sedum mats, which are available in Europe, and we are growing them in Australia. I tend to use smaller pot plants, and I've got various mixes available, which are for coastal areas or western hot areas, tropical areas, semi-shade, and a biodiversity mix. And they can all be mixed together as well, depending on what type of project you've got. So there's quite a few different plant species that work. Typically, all these plants require low maintenance, succulent type of plants. This is for green, lightweight green roofs. All these ones are. On the rooftop gardens, you can virtually have anything growing that you might have in a garden. But I'm not really talking about those too much today. I'm talking about green roofs, which are for lightweight fixtures. And so these are the sorts of plants you would use for that. I have a table here of weights. So the lightest system here is system number 1, and the total dead load is 101.2 kilos per square meter. So these things are available. If anybody wants them, they can have them. On that one, we've got plants we've got a fabric mulch, we've got an irrigation system, a green roof soil mix of 50 millimeters, and an urban scape mix of 20 millimeters. That's the mineral wool I was telling you about, geotextiles, drainage cell, and it's a total buildup of 105 millimeters. And to the right of that, to the right of that, you'll see, I'll just move my pictures of you all. There's a mix there that says it's 190 millimeters. That's the far right one. And you'll see that that one weighs 249 kilos a square meter. So it's quite a bump up. And in that one, you've got 150 millimeters of soil. So that's sort of on the upper end of what a green roof would have in the mixture. And it's a total buildup of 225 millimeters. So moving into the flooding side of things, again, for any ecologists out there, there's a thing called urban stream syndrome. And what that is it's quite all over the world. It's where cities are shedding their water quickly into drainage systems, sometimes open drainage systems like that on the right there. They have no biodiversity value whatsoever. They stink, and they, the water quality in there is extremely poor. It's quite often toxic. If you don't have good drainage systems, speaking, you'll get flooding like Parramatta there. And that was a couple of years ago, but I don't need to tell anybody about floods if you're in Australia at the moment. It's everywhere. So the urban stream syndrome is the way the water's, even water coming off car parks comes off at a different temperature. That different temperature stops certain invertebrates living in the water, like dragonfly larvae and so forth. If you haven't got those invertebrates, you haven't got fish. So, forget about fishing. All of these river systems prior to Australian habitation by white people, the streams used to flow consistently all year, and they were all drinkable. So when I say consistently, they nearly always flowed. Nowadays, with all of our hardscape going on, those streams flood or are dry, and it just continuously goes backwards and forwards. And again, you can't have fish in that sort of situation. So that's what we've done to the country, and green roofs are a solution to that. Western Sydney University, we've been working on this urbanscape detention roof, and I'll briefly show you again a sample of that we have here, which essentially, it's the same as the other one, but at the bottom of it, you have a detention layer. In this case, it's a 40 millimeter one, so it holds 40 litres per square metre, but it's basically airspace. It's a honeycomb system, and then underneath that, we have another fabric that slows the water exodus from the system. So basically, the water comes into the green roof, it gets kept in this honeycomb, and it can't get out quickly, so it comes out slowly. Now, Jacob mentioned flat roofs. That's a possibility with this system. Obviously, you've got to have your drainage holes properly, but flat roofs are a possibility for this, but it also works on the 1 in 100 slopes. So that's where I am there. That's the research they've been doing, and we've had some quite publicity about it today, actually, in the press and so forth. If you read the Daily Telegraph or the Adelaide Advertiser or watched ABC News, it was on there. So we had some good information, good promotional activity for that sort of work today, which was really lovely. So just as a building here, typical building, no green roof. The water's running off the building. This is what they might do these days. It goes into a bioswale. It might go into a big pond or tank. And what else have I got there? And it takes a certain amount of time to get to those locations. If you have a green roof on it, so a green building, the bioswale can still be there, but it goes from the building to the pond. The pond's reduced in size. The time frame from going from the building to the pond is greatly increased, just like it would have been when the whole country was covered in forests and our creeks were drinkable. So that's the sort of thing that's happening with the detention roof. And this is our stormwater detention setup at Western Sydney University. We're testing different different levels. The testing has been quite intense. Those roofs are on weighing scales, 3-ton weighing scales. They've got tipping buckets on them, and they're measuring every 15 seconds how much it weighs. And every time the bucket tips, it tells it how much 75 mils of water runs off the roof. And that's been doing that now for 2.5 years. And it all goes on the web, and all the data's there, just millions of points of data. And we've got guys at the university analysing all that data, and they've issued a paper which Jacob already mentioned, but there's another one coming out now which is specific to the detention roof. The detention roof works in this way. On the left-hand side is a typical green roof where the water runs down through the soil and into a drainage layer. The next step up from that on the right is that the water runs down and then it runs into a mineral wool, which this mineral wool component holds 85% of its volume in water. So it's like a big sponge, and it's a little bit like a wicking bed, if anybody knows what they are in planter boxes we mentioned before, but wicking beds in planter boxes are the way to go. And so this sort of sponge system is what you use. And when the water drains out of these various systems, I'm going to move these pictures away again. On the left-hand side, your typical green roof, the water's just running down through the soil. Now, it doesn't run equally through soil. Variable component. So it runs straight through. It pretty well runs through immediately and starts draining when it rains. But when on the middle picture, it's got the mineral wool, which means that the mineral wool absorbs it and it runs through a little bit slower through that. And on the right-hand side, you've got this detention layer, and it won't run at all out of the roof until the detention layer is full, and then at a slow pace. I have a lot more information on this. I've tried to keep it pretty simple. This is a detention roof in the States. Looks like a beautiful roof, but this one holds, I think it's about 100 millimeters of water over the whole surface of that roof and lets it drain out slowly. Knauf, who make these products, make a few graphs, and if you have a big roof or a roof that you want these graphs for, they'll prepare them. So this one on the left-hand side tells you what the temperature outside of your roof will be if you put a green roof on it versus not having one. The middle one is all about the energy consumption of the building, and the right-hand one tells you how much water you'll use and how much will drain off that roof based on what city you're living in on the last 20 years rainfall events. This year would be a bit different, but there it is. So where I can help on people is the specifications. I do green roof design work and write specifications up for people so that I tell them exactly what layers they need, how much and what soil species and so what plant species and so forth that we can have. So all that's information. I do have a number of CAD drawings available for all of you guys. Jacob and me will put something together so you can get our information. We haven't decided how that will be yet. The mineral wool component from Knauf, I'll just tell you a little bit about that. It just comes from 3 different types of rock. They're heated and they're spun into a wool, and they're made into large rolls, and they get rolled out on the green roof, or cubes which get mixed in with the soil and so forth. So that's how that's worked. That's some specifications on the Urbanscape mineral wool. I told you already, it's 100% pure mineral. It's got nothing else in it apart from rock. Excellent water retention, greatly reduces peak discharge of water. It's designed for building life. So you put one of these green roofs up, and the idea is it's going to last as long as you're building. So some maintenance is required, but that's the purpose of this. And it's fully recyclable. It comes with this environmental product declaration, which the likes of Lend-Lease and so forth need. They won't use anything unless you have one of these. I've demonstrated that already. So here we are on the top left-hand side there. We've got waterproofing down. Let's pretend Jacob's done that for me. And I've put some core flute on top of it. Actually, I wanted to show you a photo. I'm doing a job at the moment where I just went there the other day, and through all of Jacob's assistance in saying, you know, there can't be any rubbish on there, I'm finding it extremely difficult with builders. I mean, this job had nails just strewn all over the waterproofing and ladders and things. And I'd already told the man about it. It just seemed to be like talking to nobody. But anyway, there it is. So that's got
Now
to be.
you have to start being like very neurotic and just keep repeating yourself, and
Yeah.
it's quite frustrating.
It's just, yeah, no, but it's just like they're you know, they'll tell me yes, they'll do it, and I'll come back to site without any warning. And I mean, even when I come back and I've told them I'm coming, they just leave all the nails all over it. I mean, it's just, anyway, I've been landscaping a long time, and I've had lots of things like that happen to me. But this roofing stuff is critical. So yes, I have to be neurotic, but I also have to. I really have to enforce it. And we talked. Jacob and me talked about contract conditions recently, and how that needs to be written into subcontractors. That if these subbies come along and damage the waterproofing, it has to be tested again, and they have to pay for it. So there's, you know, they're the things that I think we need to do. This one's got a leak detection system on it. Again, Jacob and me have been talking about this, but this is the low voltage one. So we put it around the edge, the guy's testing it. They've also gone around with a sharp implement and tested all the joints and things, which I thought was pretty good. And as a green roof specialist, I am avoiding being responsible for the waterproofing, and I'll let the likes of Jacob and do that, and the build to be responsible. So there's a bit of philosophy about that. I can talk a lot, but my philosophy is that a building needs to be built by a builder, suitable, and the waterproofing needs to be suitable for the circumstances that are going on it. And if they know there's a green roof on it, they have to do all these things that Jacob's just explained, and that's their responsibility. We can talk about that more. So here I'm laying down drainage cell on the top left-hand side. On the right-hand side, I've put down geotech fabric on top of that drainage cell. That stops any soil or particles going into the drainage cell. I've also put on a 20 mil layer of Knauf mineral wool, and the sub-irrigation pipe, which is a special pipe too, that needs to be capable of not allowing roots to grow into the drippers in it. So the bottom left-hand side, we're just connecting those irrigation pipes up. Top right-hand side, I don't know what I'm doing. And top left-hand side, bottom right-hand side, I mean. So here we're just putting in soil up. We've craned it up on this particular job. We blow it up, we crane it up. There's all different methods. Planting it out on the bottom right-hand side. On the left-hand side, there's a safety wire that is needed for maintenance people. That needs to be figured into the roof. That's that roof after about a year, and those kangaroo paws, anagasanthes they're called, they're thriving on 65 millimeters of soil and the mineral wool layer, so we can grow some nice big shrubs there. That's 600 meters of the mineral wool being put down ready for planting, and the right hand side is that job's planted out about a year later. So again, that's what's happening in Erskineville in Sydney. So they're starting to come about here. Shell house in George Street in the city. We had to crane all that material up to that roof, and that's what's happening up there. So succulent plants on a lightweight green roof. Roofs can be on sloping roofs as well. So this is at a much higher slope than the one in 100. And there's various techniques of doing that. On the bottom left-hand side, this is a plastic membrane that can hold soil in place and lets water drain through it. And as it gets steeper, there's more and more requirements. They get stainless steel cables through them at a certain point, and then after that, they get even more treatment. This is the lightweight green roof, on a modern building in Germany. That's got the Urbanscape system on it. And that's pretty much for me. So any questions, I'm happy to, man, I'm not sure how we want to do that, Jacob.
So, yeah, like, I mean, we might as well just open it up for like everyone will obviously can ask whatever, like nobody ask any questions to the chat. I'm just looking right now.
Yeah.
But That was fantastic presentation. That was great. I really appreciate that, particularly for costing and the weight. I find that's a good info for like a waterproofing contractor.
Yes.
And from my point of view, I also think it would be good um to just come up with some sort of strategy, right? Because I find that often the green roof um will be in architectural plans, right? But as soon as the builders comes in and they look at the cost, they'll be like getting rid of it, like in value engineering process, like that would be the first thing to go, right?
Yeah,
So
well, the builders, as far as, a plug for you guys, one of the biggest things is that the builder says, look, we can't even waterproof a bathroom. We're not going to waterproof a roof. So, I don't know, it seems like crazy, but that's what they say to me. And yeah, builders just generally don't want to do anything new or anything risky. And I guess I can understand that.
yeah, that's in a sense on us, right? Like, I mean, like
Yeah.
we obviously the industry's been having especially lately, like everyone's been talking about it, like it's getting a lot of publicity that there's a lot of building defects and a lot of it is waterproofing defects, right? So there's no denying there that we can definitely do a better job of waterproofing green roofs, right? So that was what I was sort of talking about, right? Like it really is not that hard, right? I waterproofed like in Canada back in the day, like I mentioned to you, Robert, like we would waterproof green roofs all the time. It just almost becomes like it's not a novelty anymore, right? Where here when I see one, like I immediately I get all excited and I want to jump all over it. But then the next thing you know, they look at the cost and it is very cost driven. That is a bit of a problem, right? So
Yeah.
so definitely as far as the policies go, like I think that's the way to go too. Just to get some and I think they've recently started sort of working on that a little bit, but maybe you can tell us like where are we at when it comes to like sort of policy and
Well,
mandating any sort of
well,
green roofs, like
well, like I would have said to you 2 days ago, I don't know, but as of
yeah.
yesterday, with Sydney Water and Blacktown Council and Penrith Council, all understanding what they've just achieved with what Western Sydney University has just achieved, and the proof of it, and then the amount of flooding we're getting. I mean, they're talking about building a multi-billion-dollar dam here and upgrading the Warragamba Dam in Sydney. It mainly be through flood control, and this would be another way of doing that and greening up the city and cooling down the city. So, but I'm just noticing one of the questions that's come through on the retrofitting green roofs in old buildings. So look, the main thing is that we've got that potentially 100 kilos a square meter that we've got to consider. So typically, I would say I'm not putting a green roof on your building unless an engineer has provided me with evidence that it will work. Now, in concrete roofs, they are mostly capable of holding 300 kilos a square meter. So that should not be a problem ever. I've had
Yeah.
some issues with steel roofs. The Lysart on one roof said that they won't guarantee the steel if there's soil directly on it. We had an issue with that where we provided a thing called aqua panel, which is basically slightly lighter than your typical bathroom floor, but it can be sealed between the panels like a bathroom. And again, your waterproofing would go on top of that. And we can do that, and then that keeps the steel roof dry, so they don't lose any of their guarantees on the steel. But again, the weight's the thing. Typically, your big sheds that should be green roofs in Europe, but not here, they will usually only hold about 45 kilos a square meter. So that's a problem. But if they built the shed for a green roof, the increased cost of steel would be about 10%. And the construction costs would be nothing more, because it's the same to put a slightly bigger girder up there as it is not. So the building cost maybe 2 or 3% more if it was capable of holding a green roof. And that's so those large sheds that are on our freeways and things in industrial estates in Europe, they're all green. And
Yeah, that is a very good point. But also, like, even say all the collarbone roofs that I see here on like warehouses or industrial facilities, like I kind of struggle to understand why would you want to use collarbone on a flat roof. Like I find it, like, I understand steel deck and like like a warm roof assembly, right? But it kind of blows my mind that they just want to like put a collarbone roof, and they fail all the time too. Like I actually, funny enough, I just work on like a few repairs on just flat collarbone roofs, and
okay.
even without anything on it, they tend to fail. They just leak a lot.
Okay.
But but generally speaking, like as far as retrofitting of the existing concrete roofs, that's just super easy, right? Like you can upgrade your waterproofing for most part quite easily, right? If it's required, like maybe your waterproofing is already pretty good, like who knows, right? Like, but like if the waterproofing is not the best, like you can always upgrade waterproofing quite easily. And on concrete deck, like they have really good capacity for holding a lot of weight, right? So that's really, and for most part, I think in Australia, on all the multi-residential buildings, that's what we see predominantly, just concrete decks for roofs, right?
So I've just put my email address up there for anybody that wants any further information, and I can send you some of those tables out or so forth. But that's if you want it quickly. Otherwise, Jacob and me will prepare some form of talking to you again and helping you.
Thank you, Robert.
Yes.
Just one more question. When we say a lightweight green roof, so which type of weight we are talking of? So
on that weight scale table that I gave you, I'm using 100 kilos a square meter as my lightest one. It is possible to do it a little bit lighter. What I'm talking about is fully saturated weight. So that is as heavy as it's ever going to get in a rainstorm.
Okay.
Yeah. Okay. Does that answer your question?
Yes,
Okay.
Perfectly. Thank you.
No worries.
Cool. Well, if anyone else have any questions, now's the time. Otherwise, I think it'll be a good time to wrap it up. I really appreciate your time, Robert. Like, it's been great, super informative, and yeah, let's do it again, I guess.
I do feel that there's a lot more to give too, so more than happy to do this again in a different seminar. And if anybody from out there's got any ideas or anything else that you would like us to cover, please don't hesitate to let me know or let us know.
All right, awesome. Well, thank you guys. Thank you very much for attending, and I think we will post that online. Actually, I think it'll be pretty good. It'd be, it'd be a good resource. Yeah, let's do it again.
No worries. Okay, guys, thanks
Thank you very much
for coming.
Thank you very much. Have a good evening, everyone.
Thank you.